Hello guys, Ecto here, and welcome to Geometry. This is a recent module. It's about doing a lot of calculations. So let's just get started with it. So we're going to go with our starting value, which is the sum of all digits in the serial number. 9 plus 0 is 9. Multiplied by the number of letters in the serial number, so 9 times 4, which is 36. So, and do we have a lip bulb? No. But if you do, you add 69 to the number. And now we're going to modify it with this symbol in the top corner up here. So what we have here is the measured angle. So we're going to multiply our number by 30. Which is... $1,080. So this is going to be our starting number for this one. On this one, we... Excuse me. The number we had before, which is 36, is going to be what we're going to use again for this one, but we're going to carry on with this one first. You see 3 shapes looping here. We have square, triangle, triangle for this one. So this is known as down, square, triangle, triangle. And then what we're going to do is use these equations to get a final number. There are these 3 values which you should use the numbers the module uses, which are these numbers, just so there isn't any variations. I put them here just in case we need them. Those values being pi, the square root of 3, and the cotangent of pi over 7. So let's just get started. So our first one is a square where we just square our current value. Do note that if at any point our decimal places gets longer than 6 decimal places, we shall round to 6 decimal places. And if if the integer part gets larger than a million, we're going to modulo by a million. Or if it becomes a million, you also modulo it. So we're going to take 1080 and we're going to square it. And we're going to get this. So, sorry if you can hear talking in the background. So we're now going to take this to six places, or modulo by a million. So we're going to be taking the last 6 digits. So we're going to ignore this one on the front. Next we have one of the triangles. We're going to be calculating this value h, which is going to be the ports plus batteries plus 1 times 2. But since we're divided by 2 here, we can just calculate this first bit for our value for h for the triangles. So we're going to take our value that we have here, and we're going to do this times basically half of what h would be. So the ports is 1, batteries is 3, so we've got 4 plus 1 is 5. 1 plus 3 plus 5, 1 is 5. And we're going to multiply by 5. Because that's all we have to do. Because we multiply by 2 but then we divide by 2. Which cancels out. We get this, which thankfully is 6 digits long again. And since we have triangle again, we just plug this back into here. And we get this is our final number. 1, 2, 3, 4, 5, 6, ignoring the 4. Now we're going to come down to this Venn diagram and check which of these conditions this number follows. So we have our number is exactly 500,000 or lower. We have 160,000, so yes. There's a non-linear module that contains one of the whereas a list of math terms is down here. So for example, derivatives, the digit, equations x, reverse Polish notation, hidden value, even or odd is going to apply for both of these. But we don't have any other ones, because geometry is not one of the words down here. So we're going to ignore that one. The last digit is a prime number. 0 is not a prime number, so we're going to skip that one. And then pseudo contains one of the letters from the word math. We have V, C, J, and F. None of those are in math, so we're going to ignore that as well. So we go look at this sector here, which is an I. I tells us to submit only the decimal part. But since we don't have any decimal part, we're just going to be submitting 0, since we had a whole number. Okay, self-module. Let's do one more example. So we have triangle, square, trapezoid this time. So I actually didn't get any of the special value ones. So I'm gonna, before we start on this one, I'm going to talk about them. Circle is just the same as the square formula, but we multiply by pi. The hexagon one, it's a squared again, but we multiply by 3 root 3 and then divide the whole thing by 2. As you can see, all of these are the same apart from the constants, basically. Okay, the constant for this one is pi, the constant for this one is 3 root 3 over 2, and this one, the constant, is 7 over 4, cotangent of pi over 7, which of course we use these values for the irrational numbers. These are basic enough, and I think the test field calculator accurately spits out the right numbers, but if you use a more accurate calculator, you can guarantee that it's not going to remove digits that will be useful later. So let's go back up to here. So like I said, the number we had before we multiplied by 30 was 36. Little we tell me we have the perpendicular. So instead of multiplying by 30, we're divided by 2. So the number we use for this one is 18 rather than 1080. So let's go back down here again. So we have triangle, square, trapezoid, triangle. Since this didn't change, we've got the same h. H being 1 plus 2, 1 plus 3 plus 1, which is 5. So we're going to have our initial number, 18, times 5. 1, 2, 3, 4, plus 1, 5. And then, of course, we're not multiplying by the 2, because it cancels out anyway for the triangle. So this is our second number. Then we've got the number squared because of the square, which gives us 8100. We've got trapezoid, where we're going to have this variable b that we need to work out. It's nice and simple. It's going to be the last digit of the serial plus the amount of D batteries. So the other shape we haven't got is this one, which is just basically A times H, but this time you would have to include the times 2. So let's calculate B, because it's going to be this plus whatever the B is. B is going to be last digit of the serial number, which is 0, and then my D matrix is 1. So it actually just ends up being we're adding 1. And then we'll multiply by our H again, which was 5. Yeah. Again, the 2 here cancels this 2 out here, so we can use the 5 rather than 10. So we now get this number. So again, we've actually got a whole number. Be warned, with these 3 specifically, and these 2 if you... Actually, mainly these 3. These 3 specifically, you will get long decimal answers, where you would have to submit answers, and rounding works as regular rounding. So let's say if you had 5.097, you would round up better example, 0.55. We wanted to round it. For this, it'll be 6 decimal places, but let's say we wanted to 3 decimal places. We round the 5 up to a 6 because 5, 6, 7, 8, 9 before the number, you round it up to the next number. Otherwise, you leave the number as it was. If you no basic rounding, that's what it means by rounding. So, yeah, basically just rounding works as regular rounding. So this is our final number. So let's go back down to here again. Our number is exactly lower. It's lower than 5 gelatin, actually much lower this time. There is a non-leading module, no. Last digit, no. This isn't true. So again, we're going to be submitting the decimal part. Of course, we have 0 again. So I actually got 2 very lucky examples here. So, if we do this. We get another module. So I actually got 2 lucky examples and got I for both of these. So, I'm just going to show an example. Say if our number was, let's take 18, and we had the heptagon, which is this one here, we would multiply by 7/4. Then multiply that by the, of course after squaring it, yeah, after squaring it, of course, yeah, multiplied by the 7/4, then multiplied by the quotation value gives us, and we will get given this. And then this half we won't have to reduce down to 6 digits. This side we can see this is 7 digits long. So we look at the digit before the one we want, after the one we want to round to. It's an 8. So since it's greater than or equal to 5, we're going to round this 3 next to it up to a 4. That's how the rounding works. And do note, if you don't get W, which is merely the integer part, ignoring decimal places, or only the decimal part, if you get submitting 25% of the number, which is multiplied by 0.25, or similarly the number is, if you get a whole number, you have to put 6 zeros after a decimal point, like so, because this one says submit only the integer ignoring decimal places. So this is the only one where you don't put the decimal places after an integer. Either of the other two, if you have, the decimal places have to go up to 6, basically. I don't know if that happens if you have decimal places, but I know you have to do that if it's a whole number. But hopefully you understand how geometry works now. So sorry that I got really simple examples. But hopefully you understand how geometry works now, and I'll see you guys in the next tutorial. See you later. Okay, so I know this is going to be a weird jump into the same tutorial, but I decided it probably isn't a good idea just to have the 2 0 examples. So I'm going to do another example which has some of the crazier values, aka the cot and the pi in this one. The pi and the cot from here. So let's, again, we had to calculate our initial value first. Get a sum of all digits in the serial number, that is 10. Or the sum of all digits in the serial number multiplied by the number of digits in the serial number, that's good. So we're going to be starting with 40. So it's 4 plus 6, which is 10, multiplied by the 4 letters. We have 40, and we don't have a lip bulb, so we're not going to be adding 69 to it. So we have the perpendicular sign here to make sure that everything's there. Yes. Perpendicular sign, so we can divide that by 2. So we're going to have 20. So now we're going to look at the shapes. So first we have the heptagon, which has this monster. So we're going to do 7/4 times 20 squared, since of the a squared, and then the cot value, which is 2.07652140. So we get this value. Okay, yes. Just to make sure I'm going to quickly put this in brackets, yes. You never be too sure. And this is less than 60 degrees here, less than 60 degrees here, so we can leave it as is for now. Now next we have the rectangle. So ports 1, 2, 3, 4, 5, 6, 7 plus batteries 9 plus 1, 10 times 2. We're going to need the times 2 here, so that's going to be 20. So we're going to take this number times 20. So we get this. Again, we don't do any modification. And now we have the circle, which all we're going to do is take this number and square it. And then multiply it by our given value of pi. And we get this nice long decimal. And this nice sign there as well. So 1, 2, 3, 4, 5, 6. So we're going to cut off at this point, and then we can move that as well. And then 6 decimal places this way, 713,803. Then 4 does not round the 3 up, so we get to this. This is our final value. So now let's use the table. Our number is less than 500,000. We still don't have a module in the maths terms. Last digit serial number is not prime, and it does not contain letter in math. So again, we're going to be only submitting the decimal. This time we actually do have a decimal this time. So we're going to be submitting 713,803, and then if we've got it right, we get its own module. So I didn't want to interject that into it, just so I didn't have 2 examples in the video which are with 2 zeros. So hopefully you understand. But once again, hopefully you understand how the module works. And I'll see you guys in the next tutorial, which I hope is not an amendment of another one. I'll see you in the next one. See you later.